Imagine waking up one morning and finding that your compass, the one you've always relied on to find direction, is pointing in the opposite direction, south instead of north. That's not a malfunction of your compass. It's a monumental reality that Earth has experienced countless times throughout its history. It might sound like science fiction, but Earth's magnetic field has been flipping, reversing, and undergoing dramatic changes for millions of years. And it's something that's happening right under our feet, often without us noticing. In this deep dive, we were going to explore one of the planet's most mysterious and powerful forces, Earth's magnetic field. We'll trace the history of these flips, uncovering how they've shaped our planet and even influenced the course of life on Earth. And most importantly, we'll look at what the next reversal might mean for us. Could the Earth's magnetic field flip again soon? What would happen to our modern world if it did? Let's journey into the core of our planet, where an invisible force is constantly shifting and occasionally flipping. We often take the Earth's magnetic field for granted. It's something we don't think about, but it plays a crucial role in protecting life on Earth. It guides our compasses, helps animals navigate, and acts as an invisible shield against deadly solar radiation. Yet, this seemingly stable force is anything but static. Earth's magnetic field is generated deep within the planet, primarily by the movement of molten iron and nickel in the outer core. These metals move in a dynamic fluid motion, creating electric currents. These currents generate magnetic fields, and when combined, they produce the overall geomagnetic field that surrounds the Earth. The magnetic field extends from the Earth's core all the way into space, forming a protective shield called the magnetosphere. This magnetic shield deflects harmful solar winds and cosmic rays, preventing them from reaching the surface of the Earth. Without this shield, life on Earth would be exposed to radiation levels that could be deadly for most organisms. Beyond its protective role, the magnetic field is also essential for navigation. For centuries, explorers have relied on compasses, which work by aligning with the Earth's magnetic field. Birds, whales, and even sea turtles use the Earth's magnetic field to navigate long distances during migrations. In modern times, the magnetic field continues to play an essential role in our technology. Satellites, navigation systems, and communication devices all rely on the stability and predictability of the Earth's magnetic field. In fact, disruptions in the magnetic field can have a serious impact on GPS systems, satellites, and even electrical grids. The magnetic field is not a static, permanent feature. It's in constant motion, with the magnetic poles gradually shifting over time. In fact, over the past 100 years, the magnetic North Pole has been moving at a rate of about 10 kilometers per year from the Canadian Arctic toward Russia. This shifting of the magnetic poles is a natural process that has been happening for as long as Earth has had a magnetic field. However, it's not just the poles that are shifting. The entire magnetic field is in a constant state of flux, with regions of the field strengthening and weakening in different areas at different times. While the magnetic field is constantly shifting, the most dramatic changes occur when the entire magnetic field flips. This phenomenon, known as geomagnetic reversal or pole reversal, is when the magnetic poles flip places, meaning the magnetic North Pole becomes the South Pole, and vice versa. Geomagnetic reversal refers to the process where the Earth's magnetic field flips its polarity. During this process, the magnetic North and South Poles switch places. These reversals occur over long periods of time, typically over thousands or even millions of years. However, the exact cause of these reversals remains a mystery. Geologists and geomagnetists can trace the history of these magnetic field flips by studying the orientation of magnetic minerals in ancient rocks, particularly in volcanic and sedimentary layers. As lava cools and solidifies, magnetic minerals align with the Earth's magnetic field. Over time, these minerals preserve a record of the magnetic field's direction and strength, allowing scientists to create a detailed history of magnetic field reversals. Magnetic field reversals happen irregularly, with no consistent pattern. On average, reversals occur every 200,000 to 300,000 years, but this timing can vary widely. Some periods of time may go by with no reversal, while other times, reversals may occur more frequently. For example, the last reversal happened about 780,000 years ago, and since then, the Earth's magnetic field has remained relatively stable. However, there is evidence that the frequency of these flips has changed throughout history. The most recent reversal, called the Brunhes-Matuyama reversal, occurred in a period of rapid changes in the Earth's geomagnetic field, and it has been thousands of years since the last one. This means we could be due for another flip soon, although it's impossible to predict exactly when it will happen. By studying the geological record, scientists have discovered that Earth's magnetic field has flipped many times throughout its history. The evidence is written in the rocks themselves. When lava flows or volcanic rocks cool, they lock in the direction of the Earth's magnetic field at that moment. Scientists can use these magnetic fingerprints to map out when and where past magnetic reversals occurred. Through this study, researchers have discovered that Earth has undergone hundreds of geomagnetic reversals over the past 160 million years. These reversals have played an essential role in shaping the magnetic environment of the planet. While geomagnetic reversals have been a natural part of Earth's history, you might be wondering, what happens to life on Earth when the magnetic field flips? How do these dramatic changes impact our planet? The most immediate concern when a geomagnetic reversal happens is the potential disruption to Earth's magnetosphere. During a reversal, the Earth's magnetic field becomes weaker, which could allow more solar radiation and cosmic rays to reach the surface. This could have significant effects on both living organisms and modern technology. One potential impact is an increase in radiation exposure. For most of Earth's history, the magnetic field has protected life from harmful solar radiation. However, if the magnetic field weakens or fluctuates during a reversal, there could be a temporary increase in radiation reaching the planet's surface. While Earth's atmosphere provides an additional layer of protection, this increased radiation could have negative effects on both humans and wildlife. Our modern technology, which depends heavily on satellite communication, GPS systems, and electrical grids, could also be affected by geomagnetic reversals. The weakening of the magnetic field could lead to an increase in the number of solar storms or geomagnetic storms, which can interfere with communication signals and disrupt power systems. For example, solar storms can damage satellites in orbit, disrupt radio communications, and cause power outages. A geomagnetic reversal could increase the frequency and intensity of such storms, potentially leading to widespread disruptions in communication and technology. Many animals, including birds, sea turtles, and whales, rely on the Earth's magnetic field for navigation. During a geomagnetic reversal, these animals may experience temporary disorientation as they depend on the magnetic field to guide them during migration. While most animals may be able to adapt to the changes over time, there could be short-term disruptions in their ability to navigate. For humans, the most direct impact would likely be felt in the form of increased difficulty in using magnetic compasses for navigation. While modern technology has largely replaced the need for traditional compasses, some remote areas and certain types of navigation systems still rely on magnetic guidance. With the magnetic field having been stable for over 780,000 years, you might be wondering, is the Earth's magnetic field due for a reversal? And if so, when might it happen? Scientists have been studying the magnetic field closely in hopes of predicting when the next reversal might take place. Currently, the magnetic field is weakening at an accelerated rate, around 5% per century. While this doesn't necessarily mean that a reversal is imminent, it does indicate that the field is in a state of change. Researchers have also noticed that the magnetic poles are moving. The magnetic North Pole in particular has been moving faster in recent decades, shifting towards Russia at a rate of about 10 kilometers per year. While this movement is not directly linked to an impending reversal, It is a sign that the magnetic field is far from static. Despite the potential impacts on animals and technology, experts agree that a geomagnetic reversal is unlikely to cause immediate harm to human life. While there may be short-term disruptions, especially in terms of communication and satellite technology, Earth's atmosphere and magnetic field will still provide some level of protection. In fact, the last reversal, occurring 780,000 years ago, did not seem to cause any mass extinction or permanent damage to life on Earth. While we can't predict when a geomagnetic reversal will happen, scientists are working on better understanding the behavior of Earth's magnetic field. By studying the historical record of past flips and monitoring the current state of the magnetic field, researchers hope to gain insights into how the field behaves during a reversal and what changes might be on the horizon. The best preparation for a geomagnetic flip is continued research and advancements in technology. Improving satellite systems, power grids, and communication networks will help mitigate the potential effects of geomagnetic storms, making our world more resilient to whatever the planet throws at us. Earth's magnetic field is an incredibly powerful yet mysterious force. Though we often take it for granted, it has been shaping our planet for billions of years, guiding explorers, protecting life, and helping us navigate. As we've seen, geomagnetic reversals are an important part of the Earth's history, shaping everything from animal behavior to the technology we rely on today. While we don't know when the next reversal will occur, one thing is certain: Earth's magnetic field will continue to change and evolve. As we uncover more about the science behind these flips, we are reminded of just how dynamic and ever-changing our planet truly is.